Hello, my name is Terry Heffelfinger. I'm the Director of Product Engineering, Art Research and Development, and Quality for Affinia Global Brake and Chassis. Today, April 20th, we're at Arizona Proving Ground in Whitman, Arizona. And we will be doing a vehicle test today on a Chevy 2500 heavy-duty vehicle, testing some lightweight rotors that we've received from a field complaint. We've seen recently an influx of lightweight rotors in the U.S. that have not met the OE specifications. Many of the OE manufacturers come to this proving ground to do vehicle brake system validation and verification before vehicles go into production. We'll be running a test today that is a European standard called ECE R90, which is a dynamometer procedure that's used for testing thermal fatigue to failure on brake rotors. The Society of Automotive Engineers is also working on a draft proposal called SAE J2928, which also runs similar to this procedure. Today, however, we will be doing this on a vehicle, on a test track, to validate the lightweight rotors to see if they will fail under real-world conditions. Thanks very much for watching, and we'll be seeing later in the video the results of this testing on a very important safety issue. Thank you. The braking maneuver is performed at Arizona Proving Ground on a Chevrolet Silverado 2500 HD two-wheel drive vehicle on a 2-mile oval test track. The vehicle is loaded to maximum GVW of 9,200 pounds and accelerated to 95 to 100 miles an hour on the track. The brakes are then applied at 0.5 G or 5 meters per second, which is a moderate stop, and the vehicle is slowed to approximately 10 miles per hour and then accelerated again to 95 to 100 miles an hour, and the braking maneuver is repeated. The two stops should be completed in approximately 75 seconds from the onset of the first stop. Vehicles then cool down and the brake rotor temperatures reach approximately 212 degrees Fahrenheit before the brake maneuver is repeated. Hello, my name is Terry Heffelfinger, and I'm the Director of Product Engineering, R&D, and Quality for Affinia Global Brake and Chassis. This morning, April 22nd, we're going to close the video out. We've done the intro earlier in the week with the vehicle testing at Arizona Proving Ground. We want to show where we are on the number of cycles that we've run. The SAE procedure is to run 100 to 150 cycles, thermal cycles, for this vehicle event. We have run 10 thermal cycles and already found micro cracks on the rotor. At 20 thermal cycles, we actually started to see radial cracks, and now we're at 80 cycles, and we want to show the effects of the radial cracks around the rotor. We would consider this to be a failure, and we'll now show you that video. Okay, we're doing an inspection of the brake rotor. Again, thermal cycles is what we're trying to do, and we are at 80 thermal cycles, trying to achieve a maximum of 100 to 150 thermal cycles. And as you can see, we've got multiple radial cracks around the circumference of the brake rotor. We would consider this to be a failure. We actually started to see what we would call a failure. There's a very large crack here. At 50 thermal cycles, we actually saw radial cracks going through the disc brake plate on the rotor, and this would be considered a failure. As you can see, we've got multiple safety issues with regards to this rotor, and this safety concern has us very alarmed. Animation number 1 demonstrates the failure mode of the brake rotor hat separating from the brake disc. You can see that the brake hat continues to rotate while the brake disc remains stationary. This loss of braking on one wheel failure mode could increase the braking distance to 112.4 meters at maximum GVW as compared to 63.2 meters for a fully functioning Dodge Caravan at 60 miles an hour. Maximum stopping distance for this vehicle per FMVSS 135 is 70 meters. Animation number 2 demonstrates the failure mode of one-wheel lockup, where a part of the brake rotor fails and becomes lodged and the brakes lock up. You can see that in this situation the maneuverability of the vehicle is compromised as well, and the ability to avoid potential obstacles could be difficult. This loss of braking on one-wheel failure mode could increase the braking distance to 74.5 meters as compared to 63.2 meters for a fully functioning Dodge Caravan. Animation number 3 demonstrates the failure mode of two-wheel loss where the rotor separates from the hat completely and the brake caliper piston comes out and you lose hydraulic pressure not only on the left front but on two wheels because of the split brake system. You can see that in this situation the maneuverability of the vehicle is compromised as well, and the ability to avoid potential obstacles could be difficult. This loss of braking on two wheels failure mode could increase the braking distance to 135.8 meters as compared to 63.2 meters for a fully functioning Dodge Caravan. We have been doing inspections of the rotors and pads at every 10 thermal cycles or 20 stops. This takes about 45 minutes to an hour of track time to get 10 thermal cycles. We started seeing micro cracks at 10 thermal cycles and radial cracks at 20 thermal cycles, mainly on the outboard cheek of the right-hand rotor. We have multiple radial cracks on both rotors, and we would consider this to be a failure. As you can see from the video, the vehicle braking maneuver does not look that extreme or severe, and you would expect the brake rotor to last throughout its service life many of these applications. For example, assume you were driving down a mountain grade in Colorado and pulling a boat on a trailer and you had to control your vehicle to a safe speed on the highway. You would expect that the rotor would not crack. The pass-fail criteria for the SAE J2928 procedure is that the rotor should pass 150 thermal cycles without any radial cracks throughout the brake disc surface. Additionally, the lightweight rotors that were tested on the vehicle were an average of 21.3 pounds versus the original equipment rotors, which were 25.5 pounds, or 4.1 pounds lighter than the original equipment rotors. On April 27, 2010, Link Vehicle Testing informed Affinia via a letter that they had completed 100 thermal cycles of the SAE procedure. Currently, the front rotors, especially the right front, have several significant cracks. Given the type of vehicle being tested, the current conditions of the rotors and the track design, we have suspended the test due to safety concerns. Continuing to test to the point of catastrophic failure at speeds up to 100 miles an hour is just not safe, even if we use outriggers and install a roll cage in the vehicle. The unpredictability of catastrophic component failure at these speeds, now that the rotors are cracking, is just not safe. The following photos for reference show the installation and buildup of the vehicle with the candidate brake components, video and data acquisition equipment, and Link Vehicle Testing at Arizona Proving Ground in Whitman, Arizona. Animation number 4 shows the physical differences in the original equipment design rotor versus a lightweight rotor. You can see that the mass or weight has been compromised with the missing steel. The air gap, vane configuration, and cooling efficiency of the brake rotor deviate from the OE design and can't provide the proper margin of safety the engineer designed in. These design changes need to be validated through extensive testing per an industry standard such as SAE J2928, which is a draft procedure for thermal fatigue.